So, basically what I'm going to get at is that coding is basically... so writing a program is just finding the path to get to the outcome you want. So I'm going to start with a metaphor. So let's think of a system. So let's say you want to irrigate to a city, and you know where you're starting and you know where you want to end, and all you have is two different types of pipes. So you have the straight pipes and you have the elbow joint pipes. Well, if you have obviously in programming there isn't really a limit on how many pieces you can use, but you want to get to from point A to point B using the least amount of pieces possible. So you would take the engineering process. You can take out a piece of paper, map out point A and point B, and then find the quickest path using those pieces, and then when you map that out, then when you actually build it, the water can flow from point A to point B, and that city can have water. So coding is not too different from that in a general scale. In a micro scale, there are a lot of intricacies, but today I'll only be talking about the general overarching principles of programming. And I see that there's a question, but I will answer the questions after this section. So like I said, in the metaphor, there's different pieces and parts, and you use those to get to your designated end goal. And so in programming, those pieces and parts are if statements and loops, and there are other different pieces that as you learn programming you will be able to apply, but the general mechanisms that are used to get from point A to point B, for say, are if statements and loops. And so first off, I'll talk about if statements. If statements are basically like forks in the road. So so it's sort of like if you have a sentence that starts with if. So you say, if this happens, do this. And so that's conditional. So what happens is when you have an if statement in a program, the program goes through, it sees the initial if statement, and it says, so let's say if the sky is blue, then dance. I don't know. So it will go through, it'll see if the sky is blue, so then it checks if the sky is blue, so then it dances. So, and that's a silly example, but I think it gets the point. But that's the general idea of if statements. So then the next piece is loops. So loops are exactly what you would think they are. Basically, when the program gets to a loop, it does the one thing. It does what you have in the loop, and then it loops back to the start, and it does it again, and it keeps going until it hits a point where you tell it to stop. There are two different types of loops. There are for loops and while loops, but if you ask me, for loops are basically just overrated while loops. They're kind of I mean, it's not like they're not useful. I definitely use them a lot. It's just that while loops are the more generalized term for are the more generalized mechanism. So what a while loop is basically an if statement that starts it checks every time it goes through the loop. So what happens is you have the while statement. So you have, let's say in our situation, is the sky blue? So if it goes and it hits the while loop and it says, is the sky blue? If the sky is blue, then it goes into the loop, and then it does whatever you have in the loop, and it loops back around to the top, and it rechecks the if statement. And if the sky is still blue, which I would assume it is, then it would go through that loop again, and it would keep going through that loop until the if statement is no longer correct. So, or the if statement no longer checks out. So it goes in and says, and let's say it was nighttime and the sky is no longer blue, then that it would say, oh, the sky isn't blue, so now I'm going to skip over what's in the loop and break out of the loop and move on in the program. And so the difference with for loops is that instead of setting a specific condition for going back into the loop, the for loop will, you give it an amount of times you want it to go around the loop. So if you tell a for loop that you want it to go around 25 times, then it will hit the for loop. It won't even question whether it needs to get into it, and it it'll do whatever is in the for loop, whatever functions you have in the for loop, and then it will come back to the top. It will add to the counter. So the counter in programming usually starts at 0, just because that's the way computers think. So it will start at 0 and then go 1, 2, 3. Or if you tell it to count by a different if you tell it to count by a different amount of numbers each time, then that's your decision. But so it goes into the for loop, and then so it reads through the functions in the for loop and performs the actions you tell it to, and it comes back to the top, and so it adds to the counter, and then once the counter hits 25, which is what you said, how long you wanted the for loop to run, then it breaks and it moves down into the rest of the program. And these are really useful when something uses a specific is used a specific number of times. So let's say you wanted to print something out to the screen 25 times, then you can just simply put it in a for loop that is labeled to run 25 times, and the for loop will run that print function 25 times. So, like I said, those three, but technically just two different mechanisms are what make up the majority of all programs. So the complex part and the fun part for me is finding the different combinations and finding the creative ways to use those mechanisms to get what you want out of a program. So you can start with something simple, like trying to do a math, because that's what computers are good at. They're good at math. They're basically just really big calculators that are a little smarter. So what you can do is, so computers, if you give them an equation, they'll solve it. That's a basis in programming. Well, not like a variable equation, but like if you put 2 + 2 = something, and then you print out the answer, then it'll tell you 4. So if you need to say, let's say you wanted to print out the number 31 for some reason, but you didn't want to just say print 31, you wanted to get there by using these if statements and loops, then well, you can use loops by saying, you could say, if the well, it'd be kind of weird if you already knew the answer and you were using it to find the answer, but you could say if the you could say that a variable starts at 0, and then if it is less than 30, then it goes into a while loop and it adds 10, and so it'll add 10, and then so now it would be 10. So when it comes back up to the top and checks, 10 is still less than 30, so it'll go back into the loop and it will add 10, and then it's 20, so it'll go up, and it says that 20 is still less than 30, so it goes back into the loop and it adds 10, and now it's 30, so it goes back up to the top and it says 30. Well, 30 is not less than 30, 30 is equal to 30. So 30, then it would break from the while loop, and then at that point you would just add 1 and you would get your answer 31. These examples are a little hard to find practical, and they are not practical at all, I can tell you that, but they are nice for understanding the concept. So what you'll find if you take a programming class is that you will get something, you'll get questions like that. You will be given an equation, and instead of solving it by hand, you have to solve it by using the program, or you will be given a program and you have to trace through and see what's happening. So that would be the reverse of what I just did. You would see the program that has it starting at 0 and then going into the loop and then adding 1 at the end, and you would have to say what the answer is. And these are just exercises. These aren't practical uses, but these exercises help in reading the code. So when you receive some code that someone else wrote, then you can trace through and see what the code is actually doing. So I'm going to take a break for a moment and answer some of the questions I'm seeing in the chat.